A manufacturing machine has a 5% defect rate. If seven items are chosen at random, what is the probability that at least one will have a defect? Okay, let's move this up a little bit so we have some room to work. Okay, at least one will have a defect. Well, there's two ways to figure that probability out. One way to figure out at least one having a defect, that means that one could have a defect, or two could have defects, or three could have defects, all the way up to 7 having defects. And if we find all those probabilities, we add all those probabilities together, and that will be the probability that at least one of them will have a defect. It's a rather long process. So instead, we could figure out the complement of the probability that none have defects. This is much faster. So this is what we're going to do. So the probability that none have defects, I'm going to call that just P of 0 for short now, is, let's see, that's a binomial probability distribution. So we have, let's see, 7 items are chosen, so n equals 7. The probability that none have defects, so our random variable x is 0, successes. The percent chance of that happening is 0.05. I don't have quite room to fit it, so the complement of that happening is 0.95. So our Q is 0.95. So let's plug this in. So P of 0 is 7 factorial over 0 factorial, 7 minus 0 factorial, P 0.05 to the number of successes, which is 0, times Q, 0.95, to the n minus x, so 7 minus 0. There's a whole bunch of canceling that happens here, so let's keep going. Don't forget, 0 factorial is 1 by definition. So we have 7 factorial over, let's clean that factorial up. 0 factorial is just 1, and 7 minus 0 is another 7 factorial, so those will cancel. Also, don't forget that anything to the 0 exponent is also 1. So this 0.05 to the 0 also cancels away to 1, and we're left with 0.95 to the 7. When we plug that into our calculators, the probability that none have defects is 0.6983. Now, the one thing you have to be careful of if you do the problem this way is you're not done yet. That's not what the question asked. This is the probability that none had defects, and you need the complement of that. So the probability that at least one had a defect is 1 minus the probability that none did. So we have to take the complement of our 0.6983. And this will give us 0.3017.